Imagine stepping into a luxurious spa, warm floors beneath your feet, steam rising from heated pools, hot water flowing through pipes in the walls. Now imagine experiencing this exact comfort in 350 BC. No electricity, no gas furnaces, no modern technology whatsoever. While medieval Europeans would later huddle around smoky fireplaces for nearly 1,000 years, the ancient Greeks and Romans were already enjoying central heating, pressurized showers, and sophisticated plumbing systems that wouldn't be matched until the Industrial Revolution, nearly 2,000 years later. Today we're going to explore one of history's most remarkable engineering achievements, the hypocaust system, ancient central heating, and the advanced plumbing networks that made the Mediterranean world cleaner, healthier, and more comfortable than many places would be for centuries to come. Life in the ancient Mediterranean presented serious challenges. Winters could be brutally cold, especially in regions like Greece and the northern reaches of the Roman Empire. Traditional heating methods were primitive and problematic. Open fires created smoke and were dangerous. Braziers provided limited warmth to small areas. There was no way to heat entire buildings efficiently. Public spaces like bathhouses needed consistent, controllable heat. Beyond heating, there were equally pressing sanitation challenges. Clean water supply and waste removal were critical for public health, especially as cities grew larger. By the 1st century BC, Ephesus, home to one of the earliest hypocaust systems, had swelled to over 250,000 people, making it the second largest city in the world at that time. The earliest civilizations developed creative solutions. The Mesopotamians used clay pipes around 4000 BCE. The Minoan civilization on Crete, 2600 to 1100 BCE, created the first underground sewer and water supply systems. They even invented the first flushing toilet at the Palace of Knossos, using water from cisterns, but it was the Greeks who would revolutionize indoor climate control entirely. The word hypocaust comes from ancient Greek, hypo, under, and kostos, burnt. The earliest known system was installed in the Temple of Ephesus around 350 BC, also known as the Temple of Artemis, one of the 7 wonders of the ancient world. 2 Cretan architects, Cherasiphron and his son Metagenes, designed this revolutionary heating system. Here's how it worked. 1. A wood-fired furnace was built in the basement, continuously tended by slaves. 2. Hot air from the fire was forced into pipes laid underneath the temple floor. 3. The stone floor absorbed the heat and radiated it upward. 4. This kept occupants warm from the bottom of their tutsis to the tops of their tunics. While the Greek historian Vitruvius later attributed the invention to a Roman named Sergius Orata around 80 BC, archaeological evidence confirms the Greek Temple of Ephesus predated this by nearly 270 years. The Romans didn't invent the hypocaust, but they perfected it and spread it throughout their empire. By the 1st century AD, they had transformed it into a sophisticated engineering marvel. 1. Suspended floors, suspensory. Floors were raised 2 to 5 feet off the ground using short brick or stone pillars called pilae. 2. The furnace, prefernium, built outside the main structure, typically wood-fired with careful regulation of heat. 3. Wall heating system. Hollow terracotta tiles called tubuli were stacked in the walls, creating vertical channels. Hot air from below would rise through these channels, heating the walls themselves. 4. Strategic venting. Clay flues carried hot air and smoke upward through the walls and out through roof outlets, ensuring proper circulation without filling rooms with smoke. 5. Thermal zoning. Rooms intended to be warmest were positioned closest to the furnace, with heat output controlled by adjusting the amount of wood fed to the fire. Romans introduced a sophisticated 3-stage bathing sequence, caldarium, the hot room, with very hot water pools and steam. Tepidarum, the warm transition room for massages and oil treatments. Frigidarium, the cold room with unheated pools for a refreshing plunge. Parallel to heating innovations came sophisticated water systems. Athens built a vast aqueduct system in the 6th century BC, with over 9,500 meters of underground clay pipes. The Greeks used pressurized piping for showers. The inventor Hieron even applied this technology for firefighting in Alexandria. Clay pipes with holes on top allowed for cleaning and maintenance. The tunnel of Eupalinos on Samos, 6th century BC, was considered one of the 3 greatest works in all Greece. Roman expansion. The first Roman aqueduct, Aqua Appia, was built in 312 BC, transporting water 10 1/3 miles. Romans used clay, terracotta, lead, stone, and even wooden pipes. Lead pipes, fistulae, were common, though Romans like Vitruvius recognized their toxicity and noted clay pipes produced more wholesome water. Interestingly, the buildup of mineral deposits, sinter, inside lead pipes actually insulated the water from the lead, making them safer than expected. By 33 BC, Rome had 170 public and private bathhouses. The hypocaust in plumbing systems weren't mere luxuries. They transformed ancient society. Public health revolution. Regular bathing reduced disease transmission. Proper sewage systems prevented contamination. Clean water supply saved countless lives. Romans believed warmth was therapeutic for circulation and health, social and cultural impact. Bathhouses became centers of community life. They incorporated gymnasiums for exercise, libraries for learning, and spaces for philosophical discussion. The gymnasium tradition, from Greek gymnos, meaning naked athletes trained nude, evolved into elaborate Roman thermae, affordable fees, sometimes free, paid by wealthy patrons seeking votes, made them accessible to nearly everyone engineering excellence. Hypocaust remains have been found throughout Europe, Western Asia, and Northern Africa. Famous examples include the baths of Caracalla in Rome and systems at Hadrian's Wall in Britain. Even remote military outposts on the frontier had hypocaust heating keeping. Roman soldiers warm in Germania and Britannia. When the Roman Empire fell in the 5th century AD, this technology was largely lost in Western Europe. The Black Death 1347-1362 killed a third of Europe's population, a catastrophe partly enabled by the loss of Roman sanitation knowledge. Today's engineers are rediscovering ancient Roman ingenuity, not just in heating, but in building materials themselves. Contemporary radiant floor heating. Modern radiant heating works on principles nearly identical to the hypocaust. Warm water or air circulates beneath flooring. Heat radiates upward, warming rooms gently and evenly. Energy efficient and silent operation. No need for noisy fans or visible radiators. Engineers studying ancient hypocausts marvel at the Romans' use of passive heating, a system requiring no electricity or motors, just clever use of convection and thermal mass. Recent research from MIT and Harvard has revealed another Roman engineering secret that's inspiring modern innovation. In a 2023 study published in Science Advances, researchers discovered that ancient Roman concrete contains calcium-rich mineral deposits called lime-clasts, white chunks of rock that appear as small millimeter-scale features. For centuries, modern engineers assumed these were impurities from poor quality control. They were wrong. The self-healing discovery. When MIT researchers deliberately cracked samples of Roman-style concrete and ran water through the cracks, something remarkable happened. Within 2 weeks, the cracks had completely healed. Water no longer flowed through. The lime-clasts had triggered a chemical process, resulting in self-repair. Meanwhile, identical concrete without lime-clasts never healed water kept flowing through indefinitely. The key difference: Romans used quicklime, a highly chemically reactive form of lime that we don't use in modern concrete. When cracks form and water enters, the quicklime reacts to create new calcium compounds that literally fill and seal the damage. Why this matters today. 1. Climate impact. Cement production accounts for about 8% of global greenhouse gas emissions. 2. Infrastructure resilience. Self-healing concrete could dramatically extend the lifespan of buildings, bridges, and roads. 3. Reduced maintenance. Less need for costly repairs and replacements. 4. Proven durability. The Pantheon remains the largest unreinforced concrete dome in the world after nearly 2,000 years, while modern concrete structures often begin deteriorating within decades. As Professor Admir Mezek noted, if the Romans put so much effort into making an outstanding construction material, following all of the detailed recipes that had been optimized over the course of many centuries, why would they put so little effort into ensuring the production of a well-mixed final product? There has to be more to this story. And there was. What can we learn from Roman and Greek engineering achievements? 1. Sustainable innovation. The hypocaust used passive heating principles that modern green buildings are now rediscovering. The Romans achieved comfort without fossil fuels or electricity. 2. Durability matters. Roman concrete has lasted 2,000 years because they engineered materials that could repair themselves. We're only now understanding how to replicate this. 3. Lost knowledge can be rediscovered. Medieval Europe lost 1,500 years of progress when Roman technology was abandoned. Today's engineers are mining ancient texts and archaeological sites for forgotten solutions to modern problems. 4. Integrated systems thinking. Romans didn't just solve one problem, they created comprehensive solutions. Bathhouses weren't just about bathing. They integrated heating, plumbing, exercise, education, and social connection into unified spaces. 5. Engineering serves society. The Romans made advanced technology accessible to ordinary citizens. Public baths with affordable fees demonstrated that engineering should benefit everyone, not just the elite. The next time you adjust your thermostat or turn on a hot shower, remember, you're using technology that ancient Greeks pioneered 2,400 years ago. And the next time you see cracked concrete on a highway, consider that Roman engineers solved that problem 2 millennia ago. We just forgot to ask them how. The past isn't just history. Sometimes it's the future we forgot we already invented.